Welcome back. In today's video, we have a waveform and it is shifted, and we want to know what direction it was shift in and how much it was shift by. So a phase angle of 120 was added to a 3 megahertz signal, causing the waveform to shift by some delta t along the x-axis. So we can then go ahead and list what we know. And let's go ahead. The first thing we know is that we have a phase angle of 120 degrees. I don't like that. 120 degrees. We have a frequency of 3 megahertz, e to the 6. And we know in our case that corresponding to the period of a waveform, we can say, so in a sense, a phase angle of 2 pi corresponds to a time shift along the time axis equal to 1 full period, right? So the fundamental, well, in this case, a period of sine or cosine is 2 pi, and we'd call that a fundamental period. Proportionally, a phase angle of theta in radians correspond to a time shift, which is delta t, and that is given by delta t is given by the angle theta divided by 2 pi times period t. Well, when we advance a signal, we push it to the left. So plus push a signal to the left, which is kind of counterintuitive, and negative push a signal to the right. So adding a positive phase angle pushes the signal to the left, which is move it backwards, and in a sense advances that signal. So we can go ahead and say the signal moves to the left. So let's choose left. We can then go ahead and find out by how much that signal was shifted. So as you can see, in our delta t equation, we have 2 pi, which is radians, and we have a theta, which is in degree, and t period, which is in second. And if we want second only, we would have to cancel either degree with degree or radian with radian, and either way you can pick or choose your poison. I'll just go for degree. So degree is equal to 180 degrees all over pi times radian, which is 2 pi in our case, and this is equal to 360 degrees. So converting 2 pi, and as you know, a circle, unit circle, 2 pi, and it's equal to 360 degrees. So we know that by common sense. Not sure if it's common sense, but we should know that by this level. So we can then go ahead and calculate the amount of shift. So that is 120 degrees over 360. So that's 1 over 3. And period is 1 over frequency, and 1 over 3. And we have 1 meg is 1 e to the 6. And if we have 1 over m, we have 1 over 1 e to the 6, which is equal to, okay, it's equal to -6, which is equal to a microsecond. So meg 1 over m, our meg is equal to micro. So thus we have a shift of 1 over 9 microseconds. So the signal or the waveform was shifted to the left, and it was shifted by the amount of 1 over 9 microsecond. And that's it for this problem. So see you in the next one. Bye.